All right, let's jump right in. We're about to take a little journey into the world of vectors. Now, that might sound kind of complicated, but I promise you, it's all built on a question you probably answer all the time.
So, imagine you're trying to tell a friend how to find your favorite coffee spot. You wouldn't just say, "Oh, it's about 500 feet from here." That's pretty useless, right? They're going to look at you and say, "Okay, 500 feet, which way?" See, to give really good, perfect directions, you always need two things: how far to go and which way to go.
And that, right there, is a vector. It's that simple. It's just a way of packaging those two ideas together. It's got magnitude, that's the how much, like our 500 feet, and it's got direction, the which way, like due north. So an instruction like take 3 paces north, that is a perfect vector. It's really the language of precise movement.
Okay, so to really get a handle on this, let's break it down. Every journey needs a starting point and a way to measure the steps, right? So let's look at the two most basic tools we're going to need for our map. First up, we've got the easiest instruction you could possibly imagine, the zero vector. Seriously, think of it as that little "you are here" dot on a map before you've even moved. Its magnitude is 0, so its only command is, don't go anywhere. Just stay put. It's the starting block for any possible journey.
So, if the zero vector means stand still, the unit vector is all about taking that very first step. A unit vector has a magnitude of, you guessed it, exactly 1. It's our basic ruler, 1 foot, 1 mile, 1 block, whatever. It just defines the size of a single standard step that you can take in any direction you want.
So let's just put them side by side to make it super clear. The zero vector, that's our anchor, no movement. The unit vector, that's our ruler. It defines the length of a single step. And here's the cool part. Any journey you can think of, no matter how long or complicated, is really just a bunch of these unit steps strung together.
All right, we've got our building blocks. Now we can start doing some really cool stuff, like describing and comparing whole journeys, not just single steps.
This brings us to a really key idea: equal vectors. Now, two vectors are considered equal if they have the exact same length and point in the exact same direction. But here's the crucial part, the thing you have to remember. It does not matter where they start. A journey of 3 blocks east is the exact same journey whether you start it in downtown New York or downtown Tokyo.
Exactly. This is what's so powerful. The vector is the journey. It's the instruction itself. It's not tied to a specific starting line. And that makes it this incredibly useful, portable piece of information.
So what happens when you get to where you're going and you want to get back? Well, for that, you need the negative vector. It's simple. It has the exact same magnitude, so the same length, but it points in the complete opposite direction. Think of it as the undo button for your trip.
Yep, it's the perfect way to think about it. If one vector is your walk from home to the coffee shop, the negative of that vector gives you the perfect instructions to walk from the coffee shop straight back to your front door. It's the same path, just in reverse.
Now, what about vectors that kind of share a path but aren't exactly the same? Well, those are called collinear vectors. The best way to picture this is to imagine a really long, straight highway. You've got some cars going north, some going south. Some drive for 10 miles, others go for 100. They're all on completely different journeys, but because they're all traveling along that same straight highway, they are all collinear.
So we've talked about steps and journeys and highways, but there's a huge piece missing from this whole picture. All this movement we've described is just relative. To make any of this truly useful, we need a common frame of reference, right?
This is the million-dollar question. If I tell you to go 5 miles northeast, your first question has to be, 5 miles northeast of what? Without some kind of shared starting point, a universal anchor for everyone, we're all just kind of lost. We need a way to give every single spot in the world a fixed, unique address.
And here it is. This is the big aha moment. It's called the position vector, and it is a total game changer. What a position vector does is it anchors every single point on our map to one single universal starting place. We call it the origin. You can think of it as the center of the universe for our map.
So now every single location gets its own unique address, and finding it is a dead simple 2-step process. Step 1, you start at the origin. Step 2, you just follow that point's specific position vector. That's it. All the confusion is gone, and we have a perfectly defined map.
Okay, this has been a really cool journey through the theory, but let's get to the big question.
why does any of this actually matter? Why have we spent all this time defining these things? Well, because this idea, which seems kind of abstract, is, and I mean this literally, running our entire modern world.
I mean, seriously, every time you open up a map on your phone, you are using position vectors. That incredible physics engine in a video game that makes a car crash look real, that is just millions of vectors calculating forces every second. Guiding a plane across the ocean, a rocket to orbit, even predicting the path of a hurricane, it is all done by calculating magnitude and direction. Vectors are the hidden language our physical world is written in. So as we wrap this up, just think about this for a second. From the pull of gravity that's holding you in your chair right now to the force of the wind outside your window, our world is just this incredible web of vectors. They describe all the invisible forces and paths that are shaping every single moment. So the next time you walk down the street, you're not just walking, you're executing a vector. What unseen paths will you travel today?